By this point, we've defined our leading and trailing edges, and we have the airfoil profile that we want to extrude along these edges. If we look at the field of this airfoil profile, change our color map to an implicit, and add our ISO lines in, we see that we've got this constant field that follows the y-axis. Now we want to take this field and morph it so that it falls between the leading and the trailing edges. To do this, we'll have to take that profile and remap its x and z components to scale that profile as it moves along the y direction. The result of our remap field block should look something like this. Note that our new ISO lines would remap so that they're conformal between the leading and trailing edges. And we have a new x and z component while our y is going to stay the same. So in this parameterization section, we'll see our new x, our new z, and the same y that we had in our original airfoil profile. Let's start with the new x. Here, we'll use the custom block provided called single panel wing parameterization. Our inputs here will be the leading and trailing edges and our root chord length. Right-clicking and opening this custom block, we can see the underlying operations. We start with two fields, one for our leading edge and one for our trailing edge. And these are just going to be sine distance fields radiating from either of those two curves. We then use the distance to curve from axis block to measure each curve's distance from the y-axis along the x direction. This will output two separate scalar fields, one for the distance to the leading edge and one for the distance to the trailing edge. We then feed these into scalar fields A and B, where in A, we would subtract x from the distance to the leading edge and multiply that by -1. And in B, we would just subtract x from the distance to the trailing edge. Let's look at an example of what this might look like. I'll scroll to the top just to test this out. Double-click and add my single panel wing edges just to create a test case. And from my list elements, I'll want to pull in my leading edge and my trailing edge. I'll pull these into my notebook. And pull them in to test. Now if I look at my distance to leading edge, I'll see a field that looks like this, starting at 0 and moving to 800, or half of my wingspan. My distance to trailing edge field will look like this. My A field will look like this. And my B will look like this. Now I take that A and B and feed them into this two-body field block that essentially finds the mid-surface between those two A and B input fields. To look further into that two-body field block, you can always right-click and open your custom block. Now from that field, I see that I'm at 0 at my center, -1 at that trailing edge, and +1 at the leading edge. To pull that 0 to one of my edges then, all I have to do is subtract 1 from the field we're viewing. And now I see that my 0 falls along this leading edge. Now my field ranges from 0 down to -2, and if I take my root chord length and divide it by -2, then multiply by the field we're viewing, I'll see this result. My field now spans from 0 at my leading edge to about 1200 at my trailing edge. This is going to be my new parameterized X field. So going back into my notebook, I can take that new X and drop it into our remapped field. For my new z, I can expand this block, and I can again use this distance to curve from axis block. We'll now measure our distance in the x direction to the y-axis from our trailing edge. And from our leading edge. We'll subtract the leading from the trailing, then divide by our root chord length. Now we see the field equal to 1 at our original profile, and 0.5 at the tip of our wing. Note that this is going to match our taper ratio of 0.5. We then take the reciprocal by dividing that by 1. And now we go from 1 to 2 at our tip. We can multiply that by z. And if we take that new z and drop it into our remap block, that'll mean that the z height scales in this case by 0.5. Now viewing the results of our remapped field, I can use the field viewer and see how my x and my z have scaled along this y direction.